Today, we're going to take a look at one of the most persistent and dangerous forms of modern air pollution, photochemical smog. Unlike the smog of the early industrial era, which came from burning coal, this type of pollution is formed by chemical reactions between sunlight and pollutants in the lower atmosphere. Let's break it down into some easy to follow steps. Photochemical smog occurs when nitrogen oxides and volatile organic compounds react in the presence of strong sunlight. These reactions produce harmful pollutants such as ozone, which create a hazy brown layer near the ground. This process is most intense in the summer months under high pressure systems that trap warm air near the surface. This is often known as a temperature inversion, preventing the pollution from dispersing. So while it looks like a harmless haze, photochemical smog is actually a toxic mix of gases and particulates that can irritate lungs, damage vegetation, and reduce visibility. Human causes of photochemical smog include vehicle emissions. This is often the main source in most urban areas, as exhausts release nitrogen oxide and hydrocarbons which react under sunlight. For example, Los Angeles has around 6 million vehicles, producing up to 500 tons of nitrogen oxide per day during peak summer conditions. Additionally, industrial pollution from power stations, oil refineries, and factories emit large amounts of sulfur dioxide, VOCs, and particulates. To make matters worse, the urban heat island effect, where cities trap heat and slow air circulation, can intensify smog conditions. There are some natural causes of photochemical smog, which usually revolve around wildfires, which release large quantities of carbon monoxide, particulates, and VOCs. For example, Australian bushfires in 2019 and 2020 caused record-breaking ozone spikes in Sydney and Melbourne. Photochemical smog has severe effects on health, ecosystems, and urban environments. In the short term, it can affect eye and throats, cause coughing, fatigue, and reduce lung function. In the longer term, it can lead to asthma, bronchitis, and even cardiovascular disease. The World Health Organization sets a safe ozone limit at 100 particles in an 8-hour period, but major cities like Delhi and Mexico regularly exceed a value of 200 during smog events. From an environmental perspective, ozone can damage chlorophyll, which means reduced photosynthesis in crops and forests. And in cities, smog often reduces visibility and accelerates the degradation of buildings and monuments. From an economic perspective, we can see increased healthcare costs and lost productivity in the workforce, and it can also bring disruption to tourism and air travel. For example, during smog episodes in Beijing in 2015, where visibility dropped beneath 200 meters, it caused flights to be grounded. Using Los Angeles in the USA as a case study, we can see a city that has a geography surrounded by mountains. This often means that air gets trapped from millions of cars and has nowhere to escape. In the 1960s, ozone levels regularly reached over 400 particles, more than 4 times the world's safe limit. Though in 1970 they introduced the Clean Air Act, which meant the introduction of catalytic converters and strict vehicle emission standards. This cut the city ozone pollution by over 70% by 2020. Yet LA still experiences around 80 days per year above WHO guidelines due to high car dependence. To tackle smog globally, strategies focus on reducing emissions and changing urban behaviour. This includes using cleaner transport, such as electric vehicles, and investing in public transport. Emissions control technology, such as higher use of catalytic converters and using low sulfur fuels, and also urban planning, where we introduce green belts, vertical gardens, and even zoning to separate traffic heavy areas from residential zones. Photochemical smog is more than just an urban haze. It's a symbol of how human activity and natural processes interact in our atmosphere. But as cities expand and global temperatures rise, the challenge of controlling smog is far from over. Understanding its causes, impacts, and solutions will be critical to managing the urban environments of the future.